Good afternoon. My name's Wayne Stanball. For those of you who don't know me, I'm currently, for better or worse, I'm the project leader for the Kicad project. This is probably going to be the only presentation where I don't bore you with the details of how Kicad works, and it's not a how-to. This is basically a presentation on the state of the project as it stands right now. I'm guessing if you're here, you probably have some experience with schematic capture, printed circuit board layout. So we've all used, most of us have probably used commercial tools in our careers, open source tools, various other tools throughout that period of time. So a little background, the reason I chose this path is because if you've been with a project long enough, excuse me, that you find that it really is a journey. I mean, we get people that come in and come out quick, they burn out, but the guys are in it for a long time. You really have to kind of look at it as it's a marathon. If you want to make it a go and get it to a point where it's usable for lots of people, and so one of the, like any journey, it's always important to look backwards to see where you came from. Because if I took a snapshot, like say the developer's mailing list for any month since I've joined the project, I guarantee you in that month you'll see a half a dozen issues pop up. Some pretty controversial. We've all been there, we understand it. And if you just look at these little snapshots in time, you would think, why am I doing this? I'm not getting anywhere. But when you actually go back and kind of view the project as a long-term process, it definitely, you start to realize, yeah, we've accomplished a lot over the years. So I'm going to give you, come on. I'm going to give you the brief history of the Kicad. The project's been around for a very long time. A lot of people don't know that. It was started by a gentleman named Jean-Pierre Chara, and I'm sure I'm not pronouncing that right, but in 1992, and for those of you who don't know, he's known as JP. He's a university professor in France, and he started I believe it was based on an open source C project, and I don't remember the name, and some of this I'm doing from memory, so it's a little gray. It was just a schematic capture. He ported it over to C++, and it was something for his students because he taught engineering, electrical and electronics engineering. He wanted a tool for his students to use. And basically, from 92 to 2006, he was a one-man project. It was all completely him, and I'm sure by the looks when I first joined the project, looking at the code, it was like, because the code formatting was all over the map, I was sure that there was other people probably students that had a hand in it. Originally, there wasn't even any collaboration. When I joined the project, if you wanted to build Kicad, you had to get the tar archived out, you had to download it. There was some hand-rolled make files, but there was no version control, no public access to collaborate. There was no mailing list, none of the things that we take for granted now in the project, okay? And so what happened was, and that's pretty much how it went for a long time. Late 2006, I got involved because I changed jobs to a small company that, some of the commercial products that are available were not financially, and I didn't need that kind of power. I just needed to do some test boards to lay out. And so I had examined the two competing projects at the time, both Gita and Kicad, and one of the things that Kicad had for it at the time was you could actually build it on Windows. And since I was working for a company that said, this is what we use, putting Linux on somebody else's computer was not an option at the time. My own personal computer, that's different. So that kind of pushed me in that direction, and that's why I chose the project. I had a need, and there was something there that I could contribute to, and that was one of the questions that at the dinner last night somebody asked me is, well, why do you contribute to Kicad? Well, that reason, but for quite a few years before this, I've been using Linux since '96, I want to say. Might have been my first version. I'm trying to remember, a long time ago. I kind of felt an obligation to give back to the community. I mean, I had used the open source software both personally and professionally. So, and I looked for projects for a long time, but I couldn't find a good fit. And I'm like, hey, I'm a double E. I know what's involved in board layout, and yeah, maybe I'm not the greatest programmer in the world, and I know I'm not the greatest engineer in the world, but you have to be able to do both those things to do this. It's a very domain-specific problem, writing a electronic development application. So, is it just the computer, or is it just being slow? When I joined Kicad, this is what I saw. I was like, oh my, pretty colors. I'm not trying to give anybody a hard time here, but as a we use professional tools. You start seeing the colored text and whatnot. Kind of makes you giggle a little bit. So I was like, well, that won't do. But anyway, at the end of 2006, I emailed JP, and we started getting a conversation about making it public. Let's do something. Unbeknownst to me, a gentleman by the name of Dick Hollenbeck, who was my predecessor, was also doing this at the same time. So, but because there was no mailing list, it was two separate conversations. So I had already started working on the code, but Dick took the initiative, set up the version control, and originally we were on SourceForge and using Subversion. But now we had a developer's mailing list. We had version control, bug tracking, all the things that, like I said, a lot of the younger people in here take for granted, but in the old, way back, things weren't always done that way, or at least not well. And of course, getting it to build was one thing, and then I started digging around in the code, and yeah, yay me. It was in a pretty bad state. I mean, I know people come into the project new developers, and go, oh my God, this is, and there's still a lot of legacy code in Kicad that, without a doubt, needs to be cleaned up. There's not to belabor the point, but there's lots to go in. And then we started getting some minor contributions, but now there were three primary developers. There was myself, Dick, and JP. So now that you used to have one guy working on it, you got three, now we're all part-time. Keep in mind that all three of us have full-time jobs, and this is very much up to this point, you have one guy, and now you got three guys. So things were starting to move. There was like a series of hand-rolled make files, so building it was always tricky. Didn't do any dependency checking, so you didn't know if your libraries were all there. So we used CMake as a build configuration tool. Because JP's his English isn't real good, almost a lot of the comments in the source code and even some of the source code itself was in French. So I'm like, I can't work on this because I can't even read it. So that was one of the first things I did as the project was translate all the documentation, and it was a lot, using Google Translate to English. And it was kind of funny because even some of the stuff that was in English was improper English, so I had to go figure out what the code did, and so I spent probably the first 2 years of my project doing that. We decided that we're going to use the Oxygen to do our source code documentation, that and this. Because as I was working through the code and looking at it, I would see the same 8-10 lines. I know I've seen this 10 lines of code somewhere else. And sure enough, I'd have to go through and do a little, grep the code a little bit, and sure enough, there it was. So there was lots and lots of refactoring, and I couldn't take the pretty colors in the dialogue, so I took all that out there. So, this was really a long time just to get the original code base. If you would go back and if you go out and pull commit 1 and pull like maybe commit 2000 and look at the difference in the source code, where it was and where we got to, it is significant. Not that we don't have a long way to go yet, but it's still there. Okay, so once we got the code in some semblance of where you could actually add things without the whole thing falling apart, because originally it was pretty much a house of cards. We brought in the Boost libraries because they have some pretty nice container classes for pointers and whatnot. Now some of that's been replaced by the latest C++, C++11. So some of that's been taken care of. Originally, the zone filling algorithm, I don't know how many people used it that long ago, used segments. So literally, you would do a zone, and it would fill with little teeny tiny segments. And if you ever had a board made, if you weren't careful, you looked at the end, you saw a bunch of little humps. Where the butt end of the segment was drawing, so the Gerber output file would. So So that changed. We went from the segment fill to the polygon fill. We added design rules manager. One of the things that originally there was no way to tell you, I want the trace for this net to be this thick. I want to guarantee minimum spacing between nets. So we added that. The layer management, all the layers were on all the time. Well, you start laying out a PC board, you can quickly realize you get more than a couple layers, and that becomes problematic. So we had to design, I mean, there's lots of things. Design a layer widget. Now, one of the things, the router was all manual. I mean, there was an auto router, but it wasn't anything, you know, it just basically, you couldn't do it a lot with it. But one thing that did contribute to this was, and it's unfortunate this project's gone now because of licensing issues, the free router was rather a clever tool in that it would take a Spectra DSN format, which we exported from our for schematic, and the board outline. You could port it into free router, and we had the link already to, so you would link, the JavaScript would run, and then you could use a push shove router to route your board. Very handy, and then it would save it back to DSN, and then the DSN would go back into PCB-new, and then you had the PCB-new file. So this was pretty important. This was big. We did a plugin manager because there's the old classic file format. We had, like, if you wanted to import this file format, there was this piece of code, and there was that piece of code to import that file format and these libraries. And so we wrote an I/O manager, and it's a really nice piece of code in that it's easy to add. We can support anything that anybody feels like writing, having the time to import. And most of our third party we import, we don't export to. Like if we import a commercial product, I'm not interested, me personally, I'm not interested in exporting to a tool that I don't own. But import is important. If we want to use PCB-new to add to the board, then we have to be able to import. And so we have quite a few importers. Internally, originally, I think PCB-new was 10,000ths of an inch was the internal. And so, you know, all the classic floating point rounding errors, we're all familiar with all those. You start doing things down here with little numbers, and it falls apart. So we went to nanometers, and now everything's integer. Big integers, but it's integers, and so there's no more rounding and whatnot. And you can always get from metric to English, which is kind of nice for those of us. And we keep going. A little later on, once we had the code base, we swigged out, you know, we swigged out all the public objects for Python, all kinds of import and export stuff, DXF import, DXF export, ping, SVG, most of the popular graphic formats that you can think of. We got a bomb generator, which is programmable, which is really a clever piece of programming. And then we decided that, you know, doing dialogues by code is kind of time consuming, so we changed to WX Form Builder to build our widget or our dialog box layout. And that's probably taken it's a lot easier now to do, somebody lean against to do dialogues. We have a tool where you can take a bitmap, convert it into both board and schematic objects, so you can put images in your drawing. You can also do bitmaps directly in the EE schema. They don't really mean anything on a PC board. There's an electronics calculator tool that's pretty basic, but it gives you some your basic electronic stuff. It's nothing fancy. And then we added templates, so there's quite a few templates, like some of the standard form boards, like the Stellaris standard form boards. There's a board layout with all the I/O in the correct place, and you want to do a project with that board. Say you want to make a daughter card to mount to it. You just suck that in. Everything's in the right place. The holes are in the right place, and then you can lay your schematic out around all the existing stuff. That went on for about 6 years. The three of us, and so a few other contributors. The swing help was some other developers as well. In 2012, we were approached by CERN about getting some help. And for the first time, we actually had, as part of their open hardware initiative, they kind of were under this, well, if we're going to have open hardware, it doesn't really make sense for us to have it in a proprietary file format. And so they approached the project and asked if we were interested, and of course we are, because we've all been working on this just on our spare time and our free time. So we started talking about discussions on the future development, including OpenGL rendering, push-shove routing, which Tom will talk about. That's one of the reasons I didn't want to do a demo, because I think you'll be impressed by the push-shove routing stuff. We have a new tool framework, which really makes it a lot nicer. The way the old code was pretty ugly, the way you had to develop tools. So now we have actually paid staff, and so there's a few members of the CERN staff that actually work on Kicad as part of their job, which is nice. That's a first. They also sponsored a rewrite of the board file format. We had the original file format was really limited, so we went to like a Lisp. If you go in and look at the PCB new file format, it looks very much like Lisp code. It's there was like a long discussion about maybe using XML, but I like to be able to read files, because if you're ever debugging a file parser, you know that if you can't read the file, good luck designing a good parser. So, and XML, I don't think, I mean, to me, it's not very human readable. So we went with sort of a Lispy syntax. And if you looked at it, you'd almost think it was a Lisp program. But it's very easy to read. If you could look at every element in a board file, and you can tell what it is. I mean, you don't even have to guess. Even though there's some documentation, it probably really, except for a few areas, there's not, there doesn't really, it's very human readable. And this was the last stable release, right? So basically, this is where we were in 2012. Now, a lot has happened since then. So if you're brave enough to use the head of the repo, this is what you'll see. And actually, in all fairness, one of the things that the project has really tried to do a good job of is, if you're brave enough to run the testing branch, I don't ever remember, very few times has it not compiled, and we rarely have like real catastrophic bugs, like you're not going to lose all your data. You know, we've done a good job of trying to make the project runnable all the time. So now we now have OpenGL and Cairo rendering just in PCB-new. That has not been ported over to the schematic editor yet. The tool framework, which I talked about, which makes it a lot easier to add more complicated and interesting tools to the schematic or the board editor. Push-shove routing, which Tom will talk about. I don't know if I've seen any benefit from this yet, but you know, people would come into the project and say, well, we need more than 16 layers, because originally it was 32 layers, 16 copper, 16 other. And some of the other layers were, you know, predefined. You couldn't define them the way you wanted. So we upped that to 64, but is anybody doing 32-layer copper? 28? You got somebody doing 28? Awesome. That's good. Not in this tool, but we do support that now. A couple of months ago, Dick, in his last hurrah before he left the project, was he abstracted out, and there's still some of this code in there. There was a lot of interdependency between some of the base objects and the UI code, which took a long, long time to kind of decouple those two things. And so the nice thing about this is now all of the applications in Kicad, the board editor, the schematic editor, they can either run in a single process, as Peter talked about earlier about not defining a workflow. If you're comfortable running them all in a single process, they can all be run as part of the project manager in a single process. Or you can launch the schematic editor as a standalone and edit away on your schematic that way, if that's your preference. They're both in there. The nice thing the single process gets us, before we were using, you know, inter-process communication, and there's always issues with doing that. Running a single process is now going to allow us in the future to do back and forth between the board editor. So say in the case of pin swapping or part swapping, I'm laying the board, oh, I got a cross node. Well, if I just swap those pins, my cross goes away. So we will be able to do both forward and backwards annotation between both. And that's way future, so don't ask yet. We got Eagle board, Eagle PCB footprint library and board import, so we can import directly from Eagle projects. And we also do GITA library import, not boards yet. And we got DXF import and IDF export, GitHub plugins. I mean, the GitHub plugin is rather clever. You can now do your footprint libraries. In fact, all our footprint libraries are now on GitHub. You use the GitHub plugin, and whenever they're updated, you automatically get them. And it's pretty neat. It's got a copy on write. You can, if you want to modify them, keeps a local copy on your machine, and then you can do the diff and send it to the library maintainers. Maybe they'll add your changes, maybe they won't. Or you can even do your own. If you don't like their libraries, you can put your own GitHub libraries up there and you can access them. Just you always need the URL and the library name, and it does the rest. Nice piece of code. The documentation and the libraries are split out as separate projects. If you look at Kicad, a total install right now is running around 750K, or 750 meg, sorry. If you count all the libraries, all the 3D models, all the symbol libraries, and all the Kicad binaries, and the documentation, it's quite a big project. We got this coming soon. This should be interesting. Tom's working on differential pair routing. So you guys who are doing transmission lines and high-speed stuff, that's something I'm sure you'll be interested in. And late last year, some guy named Wayne Stanball became the project leader. So this is where we are right now. And so what's next? Oh, we're going to do, did I miss one? I had to get my glasses on. That's one of the bad things about getting old. How do I get out of here? Yeah, don't worry about it. It was just, I know what's on it. What's next is we're getting ready to gear up for a stable release. Since we haven't done one in 2 years, we've been getting a lot of pressure. Hey, we want a stable release. Dick, my predecessor, didn't believe in that philosophy. He wanted people to use the bleeding edge, and so I disagreed with that. But you know how projects are. You can do what you want. I wasn't in the position to make that decision, and now I am, and we're gonna do a stable release, hopefully by the middle of this year. Once we commit the differential pair routing, we'll start there'll be a feature freeze. We'll do go through the usual steps, and do hopefully a release here shortly. So what's next? Our user interface kind of is a little old. We like to get the editable toolbars, all the things that people kind of expect from a graphical user interface. We haven't enabled, it's built into Kicad right now. We haven't enabled it because every time we do, it just creates a mess, and so we turn it back off again. And some of this has to do with WX widgets, which is the library we use, so it's not quite real mature yet. The other thing we need to do, and we know this has been a problem, is geometry libraries are tricky, okay? And right now we have basically 3. We have the one that's in Boost, there's another one that we use the source directly, and then there's, of course, all the individual functions that still are all over the place in Kicad. So we really need to have a unified geometry library. So no matter what geometry you're drawing, you're always using the same library. We want to add, this is an important one. We were talking about this earlier with the simulation guys. We need to be able to add arbitrary attributes to anything, and whether it's a net, a component, whatever. We need to be able to add these attributes so the simulators can do their job. So we can do splice right now. It's a little awkward and clumsy, but we need to go way beyond that. The symbol library editor really has some issues. We want to port all the editing tools. Right now, only a partial set of the subset of the editing tools have been ported to the new tool framework and the OpenGL and Cairo rendering. So sometimes you have to switch back and forth between graphics modes to do a full edit on PCB, and that's going to be after that. And we got 3D modeling improvements. Right now, we do 3D modeling, and it's not perfect, but it actually does a pretty good job of giving you a representation of what your printed circuit board will look like. But there's talk about using the Open Cascade library, possibly using STEP, some of the STEP formats for 3D export. So people who are doing solid modeling to put their parts together, like, you don't just make a board with parts on it, it fits in something, so usually a case or whatever. So that's something that we need to address. And of course, now that we have an easier way to do, we don't have to necessarily do the inter-process communication thing now. We're going to add pin and gate swapping and those types of features that you see in like the commercial products that will give us that'll be a big plus. Improve the selection tool. One of the things that's kind of quirky when you're selecting groups of tools or groups of objects like on a board. We currently have some issues dealing with that. This one I think is important, and this is a tricky problem to solve when you're talking about a board editor or a netlist program. You're not doing graphics or text. You have things that are connected together. How do you, so but we do need to address the cut and paste. Because people expect that to work, and we don't really have a good solution for that yet. We need to improve. The DRC's missing some bits and pieces. Drawing segments and stuff. A lot of people like endpoint snapping. Right now, you have to know exactly where you're drawing to get it to work perfectly. We need to add. There's some enhancements we need to add to the zones. A lot of people like to use keep outs for preventing things getting too close together and whatnot. We also need to port. We have a Gerber viewer as well, and that needs to be ported to. Oh, come on, wake up. In the distant future, we'd like to maybe possibly think, and that's one of the things that I'm here to talk about with some of the simulator guys, is about digital simulation and collaboration with other EDA projects and developers, and really a lot of interesting stuff here today. It was glad to be here, and then we get this complaint every time. Right now, after 2 years, we moved from SourceForge to Launchpad. And then now the bazaar's kind of died off in development. I don't know if you're familiar with that. They're pretty much, it seems to be dead. So this comes up every time. Now we do have a mirror for people who want to contribute. We do have a mirror on GitHub. It's just until we do the next stable release, I don't want to go through because one of the things we did when we went from SourceForge to Launchpad, we lost a lot of bug history and a lot of that kind of local knowledge, getting the information. So I want to be careful about when we do that. I want to make sure we have a good solution, and I'm not 100% convinced that we're there yet. So in conclusion, the project's growing in leaps and bounds. There's a lot of interesting stuff. I think if you stay and watch the auto router thing, it's pretty nice. Thank you for your interest in Kicad. There was a lot more people here than I expected, and I want to pay. The words "thank you" probably don't get used often enough in this community or in general around here, but I want to give a special shout out to Javier he put all this together for us, and CERN for making this possible, because without their donations and contributions, these kind of things wouldn't be possible. So thanks, and thank you. And before we start the Q&A, I just want to let everybody know here, I'm here. I don't fly out till tomorrow morning. So if you have some things you want to talk about Kicad, I would much rather talk to you in person than trying to do it on a developer's mailing list. As much as that is our communication medium, I find that it's not necessarily the most efficient way to exchange ideas. So if you have some ideas and you got a few minutes and you grab my ear, I'm more than willing to talk and discuss about the future of Kicad and any way that you can contribute. So so any questions? Yeah.
I just wanted to comment. I was very pleased to see arbitrary attributes showing up on your to-do list. But I wanted to encourage you to think about that as not just being for simulation. We make extensive use of that for component procurement, manufacturing process details.
Yeah, the question was about arbitrary attributes, that they're more for simulation. They are actually. They're going to, in fact, they're going to be. The goal is they're either. Right now, I'm thinking, haven't decided yet. It's either going to be generic key value pair or generic key value type pair, or a triad. I don't know how we're going to do it yet. Because to me that's what I think, because to me is the post processing, whatever tool you're going to use to post process is going to know what that key is, right? Hopefully it does. And I don't. So basically, anything that. The goal is, the way I'm thinking of the file format and working the attributes internally in the data is basically the goal is to be able to add an attribute to any object in the PCB. Now, whether that makes sense or not, I don't know, to look at that. But those attributes the schematic editor or the board editor may not do anything with them, but it'll save them and then it'll put them back out, so that if you want to post-process the net list, they'll always be saved in the net list with the object that they belong to. And if you want to post-process them, then that's something you can do both in the board file. They'll probably end up in the board file format as well. So if you want to post-process them to do any kind of simulation, they'll be there. It'll be your responsibility to process them correctly, not Kicad's. It'll just store them as pairs. Okay, now a question? I don't. Yeah, I no, I'm not a Twitter guy, to be honest with you. My plate's pretty full, so the less media. Usually the best place is either contact me directly. My email's on the. I'm okay with that. On the mailing list, it's StanballW, my last name, @gmail.com. So I'm perfectly okay with that. And if it's really a big conversation, I'm more than happy to give you my phone number and we can call and chat. I'm here yeah, I'm staying here because there's some more talks I want to see. Wait, do we have time? Okay, the question is Eagle import, both libraries, and are you boards or just the libraries? Just the. Well, okay, well, let me clarify that. Right now, only the footprint libraries and board import is supported, and that's only in the latest, I believe, yeah, it's only in the latest file format, which is XML, or it's like an XML dialect, isn't it? Their newest version 8 of their form. I'm not 100% sure, but I know right now only the board, so if you import a board, it'll render in PCB new, just like it would in. And then when you save it, it's saved. Obviously, we're not saving it back to. We're saving it to PCB new, our format, our file format. But yeah, the import is direct, and libraries as well. You can actually point to an XML file that we have this library management tool called a footprint library table, and you could actually point it and tell it, hey, this is an Eagle file, and it'll pull all the footprints out, and you can look at them just like you can any of our footprints. And then you can save them as Kicad footprints. But yeah, the schematic and the symbol libraries aren't done yet. That's after the next stable release. Yeah, I spoke, and I can't remember his name. I spoke to that gentleman. Yeah, I talked to him on the telephone, and because he contacted me directly and asked me about, are you okay if we put these on the Kicad website? And I'm like, yeah, sure. He has a whole bunch of really good videos. I highly recommend them if you're just starting out. He covers. He's an electronics engineer, and he uses that as part of his consulting job. That's how and they're very good. I've looked at a few of them, not that I need to, but I looked at a few of them just to see the quality of them, and if you're just learning Kicad, check those out. Very good.
Also check the tutorials for GSCAM and PCB out. There are several good ones. Okay, thank you, Wayne.
Thank you.